Hi everyone, it's Math with AUB. We are about to prove three humongous identities in case of integration. Mostly people directly claim and they replace just value of A, just value of A. We must have a background from where comes or occurs this situation. Let's see and find out. I have already told you, let me tell you again. If that is the case, A square minus x square root or whatever the power is, always suppose x is equal to A sine theta. In that case, x is equal to A tan theta. A slight difference between these two, constant first, then variable, prior variable, then constant. In that case, we have to suppose x is equal to A sec theta. In that case, we have free and we can also assume that x is equal to A cos theta. Okay, cool. Let's prove identity number one. It's our root A square minus x square dx. In that case, we suppose x is equal x is equal to A sine theta. A sine theta. Differentiate with respect to theta, dx over d theta. We have A cos theta. Find the value of the differential dx. We have dx is equal to A times cos theta times d theta. That's our 2, that's our 1. Utilize both these values in the original integral. We have A square minus x square. X is A sine, means we have to square both quantities. A square sine square. Okay, what is the value of dx? That is A cos theta d theta. We have done just replacement. Instead of x, A sine theta, there is a square, x square, I have written A square sine square. Instead of dx, A cos theta. From radical, take A square common. Take A square common. A square common, factored out, 1 minus sine square theta times A cos theta d theta. From trigonometry, 1 minus sine square is equal to cos square. So we have A square cos square times root A square cos square times A cos theta d theta. It's perfect square quantity. It is A cos theta d theta times A cos theta d theta. A into A square. Now we have A square cos square theta d theta. Write A square outside. Whenever sine and cosine have even powers, we switch over such identities. Cos square is equal to 1 plus cos double the angle divided by 2 d theta. For sine square, it should be minus. For cos square, 1 plus cos 2 theta over 2 divided by 2. Whenever you are going to handle sine and cosine having even powers, utilize such identities. Cos square means 1 plus cos, sine square means 1 minus sine. Whenever sine and cosine have even powers, write 2 outside, A square over 2. We have 1 times d theta, distribute 1 integral and d theta, and it is our cos 2 theta d theta. Okay, cool. A square. Now our variable is d theta. Theta, integration of 1 is theta, instead of cos 2 theta is sine 2 theta over 2 plus c. We manage the value of theta from here. Theta is equal to x is equal to x over a is equal to sine theta, or theta is equal to sine inverse of x over a, or sine inverse of x over a. It is A square over 2 instead of theta, sine inverse of x over a plus sine 2 theta can be written as 2 sine theta cos theta overall 2 plus c. Okay, cool. What we have assumed? Sine theta. We can easily manage the value of sine, that is x over a, that is x over a for sine. For cosine, we have to convert cosine into sine because our entrance is a sine, our exit must be sine. Our entrance is sine, our exit must be sine. So converting cos into sine, that is same, A square over 2 times sine inverse x over a plus sine theta. Let me convert cos into sine utilizing 1 minus sine square theta plus c. Cos square is equal to 1 minus sine square, and only cos we have managed 1 minus sine square theta. Right, x over a here, x over here. It's our final answer. A square over 2 sine inverse of x over a plus x over a times 1 minus, that is our x square. A square plus c LCM, it will become a square minus x square, a square minus x square, and a square, square root of a square is a square over 2 sine inverse of x over a plus x over a LCM, a square x square. After LCM we write a square outside the under root because a square is a perfect quantity. So we have a square over 2 sine inverse of x over a plus x over a times a square minus x square over a plus c. Now let me write this one in standard form. It is 1 over 2 a square sine inverse of x over a plus 1 upon 2 there is a square x times a square minus x square. 1 upon 2 a square, multiply a square as well. A square must be there. A square with this one. A square cancelled out. So we have 1 over 2 a square sine inverse x over a plus 1 over 2x root a square minus x square plus. It is the required identity we have to prove. 1 over 2x a square minus x square plus 1 over 2 a square sine inverse of x over a. These two quantities are present here. 1 over 2x a square minus and so on. If that is the case, a square minus x square, always switch to x is equal to a sine theta. With the facility, with the help of, with the assistance of this supposition, you can easily get rid of this square root. Nothing is the background behind this. Okay, cool. Both identities are almost identical in fashion. In positive, we have to assume 10. In x square minus a square situation, we have to assume sec. Okay, let me prove them one by one. X square plus a square dx is equal to 1 over 2 times x square plus a square plus 1 over 2 a square ln x plus x square plus a square plus c. Okay, cool. Assume x is equal to a tan theta. Differentiate with respect to theta dx over d theta. Differentiation of tan is sec square theta. Find the value of differential dx. It is a times sec square theta times d theta. For these values in the original integral we have x means a square tan square. There is x square, value of x is a tan, a square tan square plus a square. Dx, value of dx is a times sec square theta d theta. Taking a square common from the root, we have tan square theta plus 1 times a sec square theta d theta. Tan square plus 1 is equal to sec square theta. Let me save the space. It is a square sec square theta root times a sec square theta d theta. Square root of a square is a, sec square is sec, a sec theta times a sec square theta d theta. It will become a square. There is sec cube. Integration of sec cube. Let me give you a good hack. Integration of sec cube and cosec cube is given by their differentiation. Differentiation of sec is sec theta tan theta plus their integration ln sec plus tan divided by 2. The average of the differentiation of sec as well as integration of sec is the integration of sec cube as well as cosec cube can be handled with the same fashion. It can be proved by utilizing by parts for this. So integration of sec cube is sec theta tan theta plus ln sec plus tan. We have assumed that x is equal to a tan theta. We have to convert this sec into tan as well as this sec into tan. Utilizing trigonometry, a square over 2 sec can be written as root 1 plus tan square theta times tan theta plus ln. Sec means root 1 plus tan square theta plus tan theta plus c. Okay, cool. Instead of 10, we put x over a. So we have a over 2 root 1 plus x square over a square times x over a plus ln 1 plus x square over a square plus x over a plus c. Okay, just manipulate. LCM a square plus x square. We have a square plus x square over on a square plus times times x over a plus ln same situation a square plus x square over a square plus x over a plus c. Okay, cool. A square can be written outside radical as a, as it is a perfect square quantity. A square over 2, we have a square plus x square over a times x over a plus ln a square plus x square over a plus x over a plus c, x over a plus c. Let me write some crucial steps here. It will become 1 over 2 a square x over x square plus a square. I am writing x first, then x square plus a square over a square plus taking LCM. Denominator is homogeneous. Write one time, no transition in the numerator. A square plus x square plus x over a plus c. Okay, cool. Multiply 1 upon 2 a throughout, and we are going to prove this identity. Okay, hang on. Let me vary this a as well. X square plus a square over a square plus, utilizing log property, this denominator can be written as ln a square plus x square plus x minus ln a plus c minus ln a. It is a constant, another constant. Just multiply 1 upon 2 a square throughout. We have 1 over 2 a square times x square plus a square over a square cancelled out plus 1 upon 2 a square ln a square plus x square plus x constant, another constant, another constant. So that is the required result, that we have to use 1 upon 2 times x square plus a square in root plus 1 upon 2 a square ln. Let me write x first, then a square plus x square plus c, and that's our eventual. That is the required. Let's prove third identity, x square minus a square dx is equal to 1 over 2 1 upon 2 x times root x square minus x square minus 1 over 2 a square ln x plus root x square minus a square. Let's prove this final identity as well. Okay, cool. Let me write this as x square minus a square dx. In that case, we suppose x is equal to a sec theta. Differentiation of x sec is sec theta as well as tan theta. Find value of dx, shift d theta over there. A times sec theta, tan theta, d theta. That's R2, that's R1. Put both these values in original integral. We have instead of x, a sec theta. There is a square. So we have a square sec square theta minus a square times a sec theta, tan theta, d theta. Taking a square common, we have sec square theta minus 1 times a sec theta, tan theta, d theta. Sec square minus 1 is equal to tan square. So we have a square tan square theta times a square tan square in the root times a sec theta, tan theta, d theta. Both are perfect quantities outside the radical sign. They are a tan theta times a sec theta, tan theta, d theta. Okay, cool. A square tan times tan, it is tan square theta times sec theta, d theta. Okay, tan square is equal to sec square minus 1 from trigonometry. Sec square theta minus 1 times sec theta d theta. Okay, a square multiply, it will become sec cube theta d theta minus 1 sec theta d theta. Okay, cool. I have already given you idea what is integration of sec direct. That is a square. Sec cube means differentiation of sec, that is sec theta tan theta, as well as integration of sec ln sec theta plus tan theta minus integration of sec is same ln sec theta plus tan theta plus c. Here overall 2. Integration of sec cube is arithmetic mean of its differentiation as well as integration. Integration of sec cube is sec theta tan theta plus ln sec theta plus tan theta divided by 2, and this integration of simple sec is ln sec theta plus tan theta. Okay, taking LCM, we have a square, 2 is the LCM, sec theta tan theta plus ln sec theta plus tan theta, multiply 2 here, it will become minus 2 ln sec theta plus tan theta plus c. Okay, cool. Positive ln sec theta tan theta, negative 2 ln sec theta, it will become sec theta tan theta d theta same, it will become negative positive 1 ln minus 2 ln sec, it will become negative 1 time ln sec theta plus tan theta plus c overall 2. Now we have to convert this tan into sec, because we have assumed we have take supposition sec, it is our entrance, that must be our exit, it is our entrance, it must be our exit. So we have to convert tan into sec, write 2 outside, a square over 2 sec theta, tan can be written as sec square theta minus 1 minus ln sec same, tan can be written as root sec square theta minus 1 plus c minus 1. Okay, cool. Now everything is in sec, we can easily manage the exit. Instead of x we can write x over a here, x over a x square minus a square, because sec has a square, minus 1 minus ln, instead of sec x over a, there is sec square means x square over a square minus 1 plus c. Okay, cool. Take LCM and multiply, that's our final answer. X over a times x over a minus over a, x square minus a square over a. I have taken a square outside the radical sign, minus ln here x over a plus x square minus a square. After taking LCM, a square can be written outside the radical sign, only a. Okay, cool, plus c. Now a square over 2 x times x square minus a square, a into a, it will become a square minus ln x plus x square minus a square overall a plus c. Utilizing tiny property of log, this one can be written as ln minus a, ln minus a can be written as ln minus a, ln minus a. So we have something like that, a square over 2 times, I'm multiplying a square over 2 throughout, x over a square times x square minus a square, this one here minus a square over 2 ln x plus x square minus a square, this ln can be written as minus ln a plus c, constant constant, another constant, constant constant, and another constant, that's our final answer. 1 over 2 x times x square minus a square here minus 1 over 2 a square ln x plus x square minus a square, x square minus a square plus c, x square plus c. That is the final identity that we have to prove in that case. In that case, 1 x root x square minus a square dx can is equal to 1 over 2 x square minus a square plus minus 1 upon 2 a square ln x plus x square minus a square plus c. That is our recording. That is our recording. It's my tiny effort to you guys to explain to you what do you mean by integration, what is the background behind this, or how to prove identities, formulas for you. You can easily prove sec cube cosec cube by utilizing by parts, by break sec square into sec square into sec, take first one sec, second one sec square, and you are going to get it. It's all by itself. Next.